Hi guys, my name is Samuel Lopez. I am an applications engineer, and today I'm going to talk to you guys about how to improve your mesh in Ansys Workbench. So just so you guys know, I have two models that I've already kind of gone through and pre-set up. I have my original model here, which contains the original geometry that I used, and this will just show you kind of what the basic mesh looks like on the model, with just maybe a couple refinements added onto it. And then we'll go into the kind of improved mesh that I already have gone through and created for that. So let's go ahead and look at what the geometry is. Here we can see we have just like a simple, like a curved pipe with two square flanges on either end of it. This is a good geometry to kind of practice on. It's got a little bit of everything. We have some curvature in our geometry. We have some little small features here, like these little bolt holes here and the fillets just like this. So it'll give us a good geometry to kind of practice on. So let's go ahead and come back here to Workbench, and then I will open up our Workbench model for this. So just like I'd mentioned, I've already kind of come through and just created a very basic mesh for this. If we don't do anything and we just decide to generate our mesh on this part, this is the mesh that we're actually going to come up with. It's not a terrible mesh, but in general, we want to try and use hexahedral elements instead of tetrahedral elements. And the reason for that being is hexahedral elements are actually a little bit more efficient. They take up a little bit more space, and they're pretty easy to resolve when it actually comes to running your solution. So if we can get a really good hexahedral mesh, it's obviously ideal for those reasons. Now, there's a couple of different things you want to check. One of those things would be your element quality, things like orthogonality, etc., which we'll go ahead and touch on a little bit later. So if we want to go ahead and try to make this a hexahedral mesh, a couple of different things we can do. We can insert a methodology like I've already done here. I've chosen to use a hex dominant method, which is just kind of like a very basic method, which kind of forces your mesh, if it can, to be hexahedral instead of tetrahedral. And then I've also put a body sizing here. The reason for this is that with these kind of small areas here in between these little bolt holes and the sidewall, I had to kind of put a body sizing there to make sure the elements would actually fit. So if I unsuppress these and then remesh this, I'll go ahead and show you guys what this looks like. Now, again, these are like really easy, relatively quick methods to put on there, but they're not always necessarily as efficient as you'd like. So what you'll see is that we'll have a nice hexahedral looking mesh here, but our element quality actually isn't going to be as high as we necessarily like. And also, you're going to see that we have about 29,000 nodes that we're going to be working with here. If I take this off, apologies, go ahead and suppress these, and then remesh this, we can see that our tet mesh is only about 7,000 nodes. So we've gone up about 4 times the amount of nodes just to try and make this a hexahedral mesh, which isn't always desirable. You know, you want to try and keep your mesh as small as possible if you can, especially for like your preliminary analyses where you don't need a particularly dense mesh just to check if your physics is running okay. You want to try and keep it as coarse as possible and to try and have a hexahedral mesh if you can. So we're back to our hex mesh here. We'll go ahead and check the element quality next, like I'd mentioned. And your element quality you want ideally to be as close to 1 as you can possibly get it. Typically, you don't want it to be super low. This 0.03 is a little bit concerning here. This could kind of potentially lead to some problems in our analysis. If I turn on a section plane here, which I've already created to just be through the geometry, we can see that through the thickness of this pipe is kind of where we're having some of our issues here. We can see we have some kind of really jagged elements here. These ones are the ones that are kind of causing the majority of the problems. These really sharp elements here that have a really kind of weird aspect ratio and a very poor orthogonality. These are the kind of things that we would want to try and fix with the meshing methods that I'm going to show you guys here in this video. Okay, sorry about that, guys. My recorder actually crashed and I lost the second part of my video, but I'll go ahead and re-record it and put the second part here. With this one, again, I've already kind of gone through and made some changes to try and facilitate our meshing here to show you guys how to get a better mesh. So I'll open our space claim model here. And it might not be initially obvious, but what I've done here is I've actually gone through and I've made several cuts. Now, the reason we want to cut this geometry is so that we can try and simplify it into simpler shapes here to facilitate our meshing. If we have really simple shapes, we can use things more efficiently when we get to actual mechanical workbench, and it actually allows us to take advantage of a really powerful meshing method called sweep mesh or swept mesh. Now, there's a couple different ways that you can implement your swept mesh. You can pick, let's say, this body here, which is more of a square body, and we can implement our swept mesh to start from this source surface and mesh through the solid geometry here to our target surface here on the other side. And what this will do is it'll give us some nice hexahedral elements that will make up this geometry, and you'll be able to determine how many elements you actually want through this thickness. Now, obviously, this is pretty advantageous for a couple of different reasons. Number one, we'll have a hexahedral mesh, and number two, we can actually determine how many elements we want through the thickness here. We typically won't get those super sharp, jagged shaped elements that you guys saw before. The second way we can actually implement it is we can actually use it in what's called an axisymmetric style. So if I hide these other bodies here, here we go, and we apply a swept mesh to this body, what we would be able to do is we select this body like we would normally do, but when it comes to the point where we actually want to select our source surface, we select this surface, and this surface will then be rotated around kind of the central axis of this body, and we'll have kind of like wedge-shaped elements that are being swept around this, just like the geometry shape shows here. So this is obviously kind of this is exactly what we would want with this kind of curved geometry. We want to try and be able to control kind of the shape through this thickness here, and we want to make sure that the quality and the orthogonality and those type of metrics aren't super skew like they were before, with just kind of using a base sizing and a basic hexahedral mesh. So if I show all the bodies here, that's kind of the first thing I've done, and that's probably the most obvious. So this has been simplified into just basically like a curved cylinder so that we can take advantage of that axisymmetric mesh. These square bodies are also cut in half here for the flange. And then the last thing I've done here is I've actually gone through and I've cut out these little cylinders in this bolt hole here. Now, again, the reason for this is so that we have just as basic of a geometry as we can possibly get here. It's really easy just to mesh these basic cylinders, these hollow cylinders in workbench meshing. Again, we can use kind of that swept through the geometry method that I'd mentioned earlier with the square geometry here. We can use that method on each of these cylinders in both of these flanges, and we'll be able to get a really good mesh. So let me go ahead and come back here to our workbench model. And this is already the mesh that I've pre-generated here. So you guys can see we have a they're all hexahedral mesh. This is kind of exactly what we're trying to accomplish here. We want a nice hexahedral mesh with a good element quality. So if I go ahead and check the element quality here, we can see that it's much higher. Actually, it's about an order of magnitude higher. And we didn't actually have to pay for it with too many nodes. So our mesh now is about 6,000 nodes. If you guys remember the tetrahedral mesh from before, I believe it was about 7. So this is a little bit less actually even than our tetrahedral mesh, and it looks even better than the other hexahedral mesh that we've done after putting the body size and the kind of the hex dominant method on there. And all we had to do was just take a little bit of time to go through and cut this and then input those swept methods that I talked about. So with that said, let me go ahead and change this back to make it a little bit easier to view. Actually, I'll show you guys one more thing here. If we turn on this section plane, you guys remember before, it was kind of the middle of this geometry that we were kind of seeing really poorly shaped elements. But with the swept method here that I've implemented, we can see that we have really nicely shaped hexahedral elements inside through the thickness here. which is exactly what we wanted. That's the whole reason we ended up kind of cutting this geometry into like basically a curved cylinder. So it's just one thing to note as we go through this here. So to kind of take you guys through this, as I'd mentioned, the first thing we mesh here is these cylinders here that I'd mentioned that I'd simplified inside the flange bodies here. Now I've decided to do one mesh method for all 8 of these cylinders. So here you can see we have all eight of these bodies selected in this, and that's okay because each of these bodies is very, very simple, and the automatic source target selection method should be able to determine which bodies to sweep and how to sweep them fairly easily. Basically, the way it's going to work, as I'd kind of alluded to before, is when you have the automatic selected, I'll go ahead and zoom in here and I'll select this body here. We'll hide all the other ones. So if we have this body selected and we're using the automatic method here in our source target selection, what it's going to do is it's going to try and pick a face that has a very similar shape and area to the face on the opposite side. And it's going to actually sweep from the face that it picks, or the source face, through your geometry to the opposite face that it picks, or the target face. Now, once it meshes that, we can actually choose a couple of different options here. In this case, you can see I've chosen to do a number of divisions. So in this case, you guys can see I've chosen to have 5 divisions through our geometry. And if I come back to our mesh here, you'll be able to see that we have 5 divisions indeed through our cylinder here. Now, these may not necessarily be perfect, but as you guys were able to see with the element quality, it's actually not too bad. And we can even further improve this by adding just a little bit of a mesh sizing refinement here, but we don't necessarily need to, at least not immediately, because our element quality is actually pretty high, which is good. The next mesh method that I used here is actually for the cylinder here. So if I go ahead and hide all these other bodies, I'll show you guys how this one works. Now, like I'd mentioned, we have the body selected, but down here in source target selection, you guys can see I've changed it from automatic to manual source. Now, sometimes it'll have problems, or it could potentially have problems depending on your geometry, automatically picking a face, or sometimes it's just easier to kind of make sure that you want like an axisymmetric mesh in your part. And so that's when we use our manual source. I could also have picked this face and tried to sweep it through the geometry this way. This would be kind of closer to that cylinder that I just showed you, where we pick our source face to be this face, for example, let's say, and we're going to actually sweep through our geometry rather than revolve around our geometry. Both would work. It just kind of depends on preference. In this case, just to show you guys how the axisymmetric works, that's the method I've chosen to go with here. So we have our manual source selected from our options here. You can see we have automatic, manual source and target, and then automatic thin and manual thin, which we can talk about later. But we have our manual source, and then I've selected this face. So again, it's going to kind of revolve this face when it tries to mesh around the central axis of this entire geometry and just give us that nice mesh that we talked about earlier, kind of around here. This time I just left the sweep number of divisions as default. You can change this to be as high or as low as you want. In this case, we don't need it to be particularly fine, so I just left it as default. And you guys can see that we have a pretty nice mesh being generated here using that axisymmetric method. So this is perfect. This is exactly what we would be trying to achieve for a part that's shaped like this, which isn't necessarily straight, has some kind of weird curvature to it. This is a good way to mesh those kinds of parts. Now let's see. The last part would be these kind of square geometries here. Now again, this is just to show you guys how the manual source works as opposed to using the automatic method. Again, I've changed our source target here from automatic to manual source, and I'm just picking the manual source here, and it's going to extrude through the geometry to the target here on the other side. You can do this either with axisymmetric, or you can do it just with, like a normal body here that you want to extrude through your geometry also. And here I've picked our sweep number of divisions through the thickness to be 2. And if I turn on the mesh back on, you'll be able to see that that's exactly what we have here. So yeah, we have a very nicely meshed geometry here. Again, our element quality also looks really nice. We don't, we don't have to worry necessarily about running into meshing errors with this specifically. Now, one thing I will note with this geometry, if I come back and turn this off, I did remove this fillet on the inside here in Space Claim also. It would be relatively easy to mesh that with Space Claim. I just wanted to show you guys, you don't necessarily need all the features. Sometimes it's easier to kind of remove some of those smaller features. I left these other kind of cylinder bodies in here just to show you guys, or just kind of demonstrate that you don't necessarily need to remove everything. You just you can either leave them in or kind of simplify your geometry based on what your actual output is. So with that said, hopefully this was a helpful video. If you guys want to see more related to this topic, or if you guys have any questions, just leave them all in the comment section. Thank you guys very much, and you guys have a good one.